Hi everyone, this is Mr. Richmond, and for this video I'm going to walk you through how to complete your simple motor. So I've got 3 D-cell or 1.5 volt batteries here. That's going to provide some voltage and current into my circuit. I've got a permanent magnet which I'm going to attach to the top and bottom of my solo cup. I'm going to take 2 safety pins and using some tape I'm going to secure them to either side of the solo cup as well. And I want to make sure that the eye holes in which the motor is going to feed through is nice and symmetrical. So ideally they should be as even as possible. And I'm not going to waste too much time doing that right now. I'll show you what a finished product should look like. And then I'm going to take about 2 feet of insulated copper wire, and I'm going to wrap that around one of the D-cell batteries. And that is going to act as my motor. So this is a little tricky, but you're going to wrap it around your D-cell battery, and ideally that motor should have the same or similar circumference or the area around that battery. So I'm going to hold all those together, and then I'm going to tie those loose ends by wrapping inside and out. And for the sake of time, I'm not going to show you what the finished product looks like, but it's going to look kind of similar to this. And ideally, again, you want your motor to be as symmetrical as possible. And what I mean by that is that the length of either side of either loose end on my motor should be about the same, roughly 1 inch on either side. And if we were to think of this as an angle, this should be flat across or 180 degrees. And that's going to feed into both sides of my safety pins, into the loose holes. And I want to make sure, because I'm going to connect this to a circuit eventually. And the tricky part about this is I want to make sure that I've got enough space in between the motor and the magnetic field where it's going to clear. So it should be high up enough where it's going to not come into contact with the magnet. Otherwise, it's definitely not going to spin over. And I want to make sure it's close enough that the electrons are going to be passing through this motor are going to be coming into contact with the magnetic field. So it's about finding a pretty even balance between the distance between your motor and the magnetic field. So we're going to have a look at the finished product in just a second. So I have my motor through the safety pins, and I'm going to connect the lead wires to my voltage source. I want to make sure that I've got good metal-on-metal contact so I can make sure that the current is carrying through. I'm going to attach this to one safety pin and attach my lead wire to the other safety pin and back to my voltage source. So right now I have a current running through my copper wire. And one last step that I forgot to mention that's actually pretty important is that I took some sandpaper, and to make sure that I could easily transfer those electrons into this copper wire, I sanded the 2 loose ends on either side to make sure that I had good contact. And let's close that circuit again by attaching my lead wires. So now I have current running through my motor. It's close enough to the magnetic field where that's going to spin. So I want to get one more angle of this to explain what's really happening here. So you've got your motor moving around, and again you've got electrons coming from our circuit up through into the motor. Those electrons, which are creating a small magnetic field in itself, we know that from class, electrical current does produce a small magnetic field. And after coming into contact with this permanent magnet, those electrons are in turn pushing away from the magnet, causing this motor to spin continuously. I hope you found this video helpful, and good luck with your assignment.